All right, so here we have another question. We have a pattern where to decide the type of growth that it's showing. Is it linear, quadratic, or exponential? Where to write the expression that gives us the total number of squares in this pattern and say how we know it makes sense. So when I look at a pattern, the first thing I want to start by is looking at the total number of squares. I don't know, that's just my method. It's helpful for me to be able to do that. And so when I look at this, here's what I'm seeing. Step one has 5 squares. Step 2 has 8 squares. Step 3 has, that's 9 and 4, 13 squares. I also look at the pattern and I say, okay, what stays the same in the pattern and what is changing? So when I look at what's staying the same, I notice, oh, the 4 corners there, these are what's staying the same, right? There are 4 squares on the outside in each case. So that is what is staying the same. So I'm going to label that stays the same. And then what is different? That's how I'm going to do my difference. So I notice the middle of my pattern, the squares are changing. All right, so that's what's changing. But how do I actually recognize this change mathematically? Because I notice what I have inside. I notice it is a square, and it's a square of different dimensions. This happens to be a square that's 1 by 1. This one happens to be a square that's 2 by 2. This one happens to be a square that is 3 by 3. All right, so if I think about this, this is a 1 by 1. This is a 2 by 2. That's a 3 by 3. The other thing is, okay, how are these numbers changing? So from 5 to 8, that's a plus 3. From 8 to 13, that's a plus 5. And you know what? I want to figure out like what step 4 is going to be, because that's going to be helpful to me. So step 4, they didn't ask for it, but it's helpful. So I notice a 1 by 1, 2 by 2, 3 by 3. So I'm going to guess that for this one, I am going to have a 4 by 4. So what that means is, oh, come on, Mrs. Thomas. Ooh. I'm going to have a 4 by 4. And then on the outside, I have an extra little 1 here, a little 1 here, little 1 here, little 1 here. All right. So how much do I have in total? That's going to be 16, because I know that's a 4 by 4. 4 by 4, 16 plus 4, that is going to give me 20. So I know in total I would have 20 squares. So step 4 is 20. What am I doing here? Oh, I'm adding 7. So right now the rate of change is different. But I notice there's a pattern that's happening with the rate of change. So this is a plus 7. And the pattern that I see is we're adding 2 to each of those numbers. So from 3 to 5, that is a plus 2. So 3 to 5. Come on. That's a plus 2. 5 to 7 is also a plus 2. I needed that to see the pattern. We can also use, so we know that this is a quadratic growth. And the reason we know it's quadratic growth pattern is because the change in the rate of change is constant. Now, I'm going to use a table to help come up with the expression. So we're going to have our step and then our step number and then our total. So when we have step number 1, our total is 5. Step number 2, our total is 8. Step number 3, our total is 13. Step number 4, our total is 20. What we can see if we want an expression is the total is always equal to, we notice we have this growing square in the middle that is given by the step number, and because it's squared, it's going to be n squared. So if we say n, so it's step number squared plus what was our constant, we're adding 4 each time. So the expression is going to be given is going to be n squared plus 4.